All right, good afternoon. These are going to be your notes for 11-4, solving linear systems by multiplying first. Okay, and this is kind of a continuation of what we did on Friday. It's the elimination method, but this time you may first need to multiply by one of the equations to make the coefficients match. So with this system, 2x plus 5y equals 9 and x minus 3y equals 10. There isn't anything that we can add or subtract the way it is to make a variable cancel. But if I multiply the bottom equation by -2, you can see here they did that, I end up with 2x minus 2x. So that will cancel. And then we can solve. Or it is possible that you may need to multiply both of the equations to make the coefficients match. So on this second one, and it doesn't matter which coefficient you get rid of first, completely up to your personal preference. But they went ahead and multiplied the top by -2 and the bottom by 3 and ended up with a -6y and a positive 6y. My suggestion, and what they did here, is they did the numbers that would be the smallest. Okay, because we don't want to make anything more complicated than we need to. So looking at number 1, all right, get just in there. As they are, we can't add them. But if I simply multiply the bottom equation or the second equation by -2, and I'm going to show that by putting parentheses around it, I'm going to end up canceling my x's out. So I have my original equation of 2x minus 3y equals 5. And when I multiply by -2, I have -2x minus 4y equals 2. Okay. And I'm going to add those together. 2x and -2x cancel. So I have -7y equals 7. And I'm going to need to divide both sides by -7. So y equals -1. I'm going to take that and I'm going to fill it back into the original second equation. So I have x plus 2 times -1 equals -1. So x minus 2 equals -1. I'm going to add 2. So x equals 1. So the answer to this system is the ordered pair 1, -1. Okay. On example number 2, I'm going to multiply the top equation by +2, which is going to get my y's to cancel out again. So this becomes 6x minus 2y equals 4 and -8x plus 2y equals 4. When you're multiplying the equations by whatever you need to multiply by, don't forget that you have to multiply every single term. So bringing it over and multiplying it by the term on the other side of the equal sign as well. Okay, 6x plus -8x is -2x equals 8. And divide by -2. X equals -4. I'm going to take that and I'm going to fill it in my top original equation. So I have 3 times -4 minus y equals 2. So I have -12 minus y equals 2. Add 12. So y equals 14. And y equals -14. So my answer is -4, -14. Okay. Example number 3. on this one, I can multiply the top equation by -5. So I'm going to get negative 10x minus 25y equals negative 110. And then 10x plus 3y equals 22. Okay, the negative 10x and the 10x cancel. So I have negative 22y equals negative 88. Divide by negative 22, and y equals 4. I'm going to substitute that into my first equation. So I have 2x plus 5 times 4 equals 22. So 2x plus 20 equals 22. Just subtract 20 from both sides. So 2x equals 2. And then we're going to divide by 2. So x equals 1. So my answer is the ordered pair 1, 4. Alright, and my last example on this front here, on number 4, as you look, there is nothing that I can multiply either just the top or just the bottom by to make my coefficients match. So in this case, I have to multiply each of them. I'm going to choose to cancel out my y's simply because they're smaller. You could choose to cancel out x, totally up to you. So if I want my y's to cancel, they already have the opposite signs. So I'm going to multiply through by even numbers, or sorry, excuse me, positive numbers. I'm going to multiply the top by 3 and the bottom by 2. So I end up with 12x plus 6y equals 42. And 14x minus 6y equals negative 16. So my 6y's are going to cancel. So I end up with 26. X equals 26. Divide both sides by 26. And x is positive 1. I'm going to fill that back into my original first equation. So 4 times 1 plus 2y equals 14. So 4 plus 2y is 14. Subtract 4. So 2y equals 10. Divide by 2. And y equals 5. So my answer to this system is the ordered pair 1, 5. Okay, on the back side of this, let me zoom out. This example is in your book on page 418. It is your turn, number 6. Okay, and it reads, Jacob's family bought 4 adult tickets and 2 student tickets to the school play for $64. Tatiana's family bought 3 adult tickets and 3 student tickets for $60. Excuse me. The system of equations 4a plus 2s equals 64 and 3a plus 3s equals 60 models this situation where A is the cost of an adult ticket and S is the cost of a student ticket. How much does each type of ticket cost? So what we need to do here is obviously solve the system. Okay, my A's are both positive and so are my S's. So on one of these equations, I'm going to have to multiply by a negative and the other by a positive. Again, it does not matter which one you do. So I am going to multiply the top by -3, and I'm going to multiply the bottom by +4. Excuse me. So I have negative 12a minus 6s equals negative 192. And my second equation is 12a plus 12s equals 240. And I'm going to add those together. So the a's cancel out. Negative 6x, s, not x, excuse me, let me zoom in a little bit too. Negative 6s plus 12s is 6s. And negative 192 plus 240 is 48. So divide by 6, and the student tickets are going to cost $8. I'm going to take the 8 and I'm just going to go ahead and plug it into the top equation. So I have 4a plus 2 times 8 equals 64. So 4a plus 16 equals 64. Subtract 16 from both sides. So I have 4a equals 48, and divide by 4, and the adult tickets are $12. Okay, that is it for this lesson. Like I said, it's the same as we did for the last lesson, just with an added step. So the homework that goes with this lesson, 11.4, it's on page 419. You're going to do problems 7 through 14 all, and then problems 19 to 20. Okay, thank you guys and have a good day.